The heart of the solution is the software, the AE6910R, that lets you automatically or semi-automatically execute Ethernet physical layer PHY electrical test for receiver compliance using IEEE specification. With capabilities that span test configuration, instrument setup, results calculations, and report generation, the AE6910R software will save you hours of time. As you see, the software helps you to quickly check for proper instrument configuration. Then it guides you how to make connections to the device under test, enables a quick way to communicate with your DUT, automatically sets up the test equipment for each test, runs the test automatically and mostly unattended. And let's start with configuration for our tests. So we select the date rate, now it's 1000 base T1, and also we are in compliance mode, and we select DUT access method, what kind of Ethernet device to use, and the script path folder where we have the scripts controlling that device. Before you run any receiver test procedure, you must calibrate the automotive Ethernet receiver test system. The DUT input ports give the value frame calibration plane. The receiver test signal characteristics are typically affected by the signal transmission between the generator output ports and the DUT input ports. Thus, when you select any signal output parameter, set value, the signal received at the DUT input port's actual value deviates from the set value. The value frame calibration procedures compensate for the deviation of the relevant signal output parameter actual values from the set values of the required parameter range. And as you see, you have transmitter signal RMS amplitude calibration procedure and also the noise signal calibration procedure, which is very relevant for noise injection tests. For example, now the test automation starts by applying small noise amplitudes and increases them with a defined step size. For every set value, measure the noise amplitude with a real-time oscilloscope and calculate the SNR for the given measured TX signal amplitude. We repeat this until you reach the target SNR or until the maximum capability of the noise generator. Additionally to the SNR signal-to-noise ratio, the theoretical SQI signal quality index is also calculated according to the recommended values in the Advanced PHY Features for Automotive Ethernet specifications document. The SQI values are not mandatory, and that some DUTs use other SQI values for specific SNR values. So as you see, the value frame software includes all calibration procedures required for the automotive Ethernet receiver testing. Implement the value frame calibration procedures such that the calibration process is conducted as fast as possible and is automated as much as possible, for example, by minimizing the number of reconfigurations of the hardware connections. So our calibration was successful, and now we can run all the tests with a device which is set as a master or a slave. The oscilloscope is used for calibration only, it's not needed to run the test. And now we are performing bit error ratio verification test. The purpose of this procedure is to verify that the DUT can maintain a bit error ratio of less than 10 to the power minus 10, having a maximum channel length attached. Either manually or through the scripts, configure the DUT to slave or master, enable the loopback, and reset the bit error counter and frame error counter. Then the bit error ratio test starts. The duration of the bit error ratio test will be required to reach a confidence level of 95%. If the bit error count indicated by the DUT is higher than the target BR, the test will fail. Otherwise, the test will pass. The next two tests that I'm going to perform are alien crosstalk noise rejection with DUT as master or slave. The purpose of this procedure is to verify again that the DUT can maintain a bit error ratio of less than 10 to the power minus 10, but in the presence of a crosstalk noise source. As you see, the noise bandwidth in this case injected to the signal is 550 MHz, and again, if the bit error count indicated by the DUT is higher than the target BR, the test will fail, otherwise the test will pass. And now it's time for indicated signal quality tests for channel with decreasing quality and increasing quality for DUT as a master or slave. The purpose of these tests is to ensure that the PHY has indicated signal quality increases for a channel with decreasing noise or decreases for a channel with increasing noise. In case of decreasing quality test, the test automation starts by applying the maximum noise amplitude and decreases it at each step until the minimum value. For every set value, the SQI value is measured 100 times and averaged. To pass the test, you must change the link status from down at low SNR to up at high SNR values. The absolute SQI values may be different from the OpenAlliance recommendation. To have nice looking graphics, you can add the maximum expected SQI value, and value frame will then scale the graphic according to this value. In case of increasing quality test, the test automation starts by applying the minimum noise amplitude and increases it at each step until the maximum value. For every set value, the SQI value is measured 100 times and averaged. So now we've performed all the tests, and now it's time to look at the test results in our test report. Now I'm showing you the results worksheet where you have all the test results combined in one test report, which has HTML file format in this case, but also the Excel file format is possible. And it's quite convenient because you have the links here and you can see all the results. Another tool that I would like to show you is a frame generator. So actually it's a flexible tool for troubleshooting and debugging that complements the value frame receiver test station. It allows you to observe the response of the DUT after sending frames with noise signal injected. So the automotive Ethernet frame generator controls the DUT automatically through calling the required batch scripts. In my case, I generate the frames to test from a gigabit Ethernet port of my laptop, and I require a media converter that converts the gigabit standard Ethernet to automotive Ethernet. And the frame generator uses the APM1000E as a media converter, which is always connected to a local USB 3 port. And in the right bottom corner, you see how the protocol decoder in my Infinium oscilloscope works, because here we send the frames, and actually you can decode and see these frames with the data in the oscilloscope.